Okay, ladies and gents, this is 1.5 Algebraic Properties of Limits and Piecewise Functions. So, to start, we'll start from the very top. X plus x is to 2x, right? I need to make that more make it look more like a 2x, right? So the limit as x approaches c of f of x plus f of x is equal to, so I already know that this is 2 f of x, right? So to start, this is example 1. The limit, the table above gives selected limits of the functions f and g. What is the limit as x approaches 1? F of negative x plus g of x 2. So as x approaches 1, this is equal, so this first one is equal to 2, right? And then from there, we get this one from, that's embarrassing, my mom texted me. Anyways, limit is g of x, and then from here, we plug in 6, so it would be 6 over 2, and we get 3 from that, right? And then it's just a simple 2 plus 3 equals 5, right? And then this one we can do, so from right here, limit as x approaches 4, so as it approaches 4 from the left and 4 from the right, it is equal to 1. It's equal to 1, right? So we would put f of 1. So it's just 1 is the answer, right? And then next we have this. What is the limit x approaches 5 h of x f of x plus 2g of x minus h of 5. So from here we just plug in what we have we plug in these values from what we have here, right? So as the limit approaches h of x, so from right here we have our first value, which is this, so it'd be 5, right, times, and then f of x, so we go right here where it's equal to 6, so this is 6, and this is plus 2 of g of x, so this is negative 1 minus h of 5, so minus h of 5, which is right here, is 2, right? So right here, that is how we solve it, and then we just order of operations, and we get 17. Whoops, 17. Right. Okay, so next we have this. These are pretty straightforward. Number line is how we are taught. Number line. So the only value we have is negative 5. So we're just going to put that in the middle. Negative 5. Right. And then this one, because it's less than, it goes on this side. So this is 11 minus x. And then on this side, since it's greater than, is x plus 3 over 5 minus x squared, right? So from here, we can just plug in the values, basically. So this is as it's approaching from the, this is as it approaches from the left. So we're talking about this one. We plug in 5. 11 minus 5. And then we can find out that this is equal to -5, which is really 16. So then 16, and the square root of that is equal to 4, right? So that's how we get that. And then this one, as it approaches 5, so well, let's work out B first, because if we work out B, it'll solve C for us. So from the right, so it's talking about this side, so we just plug in -5, which this is -2 over 10, which is -1 over 10, right? So because these two values do not equal each other, then this C does not exist, right? So then let's go to this one. This one we have number line again, and then we have two values this time. So this one will start at -1. This one we start at E, and then less than. So this one is 10 minus x squared. And then this one in the middle is 26 minus 5x squared over 7. And then this last one is that's x cubed. And then from here, we could just do the plugging in. So this one is just as it approaches -1, so we have to see if it equals that from the left and the right. So from the left, we plug in -1, so it would be +1, but back to a -1, so it'd be 9. This side would be 9 for A, and then we plug it in right here, so it'd be -1, so it'd be -1 times -5, which is just 5, so it'd be 26 plus 5 would be 31 over 7. So this one, or no, it'd be 27. Yeah, 27, and then it would be equal to 3. Yeah. And then B is that it approaches E from the right. So I'm gonna plug it into my calculator real quick, and that also gives me 3. And then so this one, last one, limit of g of x as x approaches E, because they're this value and this value are different, then this does not exist. And yeah.